Welcome to This Explainer. Okay, so the next time you're on a flight, looking out the window as you land, you're going to stare right at a planet-sized secret that's just hiding in plain sight. I'm talking about those giant, cryptic numbers painted at the ends of every airport runway. You might think they're just sequential labels, kind of like parking spots, right? Well, they absolutely aren't. They are actually part of this incredibly intricate language made up of math, wind, and invisible magnetic forces. And to really crack this code, we have to start by looking at a genuinely terrifying historical mystery. Picture this. It's October 1970. A U.S. Navy C-12-1 Constellation aircraft is on its final approach to land at McMurdo Station, way down in Antarctica. The weather? Absolutely horrendous. The pilot couldn't see a single thing out the window. But strangely enough, he was actually super confident. Why? Because the compass in his cockpit was working perfectly, and air traffic control was on the radio confirming he was on the exact right heading. His instruments and the ground crew were in total 100% agreement. But as the minutes just kept ticking by, the runway never appeared. Suddenly, ATC radioed in complete panic. He was heading in the totally wrong direction. But how is that even possible? So after several really desperate attempts to find the runway, the Navy plane literally ran out of fuel. The pilot was forced to execute this completely blind emergency landing out in the middle of nowhere. Miraculously, and I mean miraculously, there were no casualties. But man, it launched a massive aviation mystery. The compass wasn't broken, ATC didn't give the wrong coordinates, so what actually happened? Well, investigators eventually discovered the plane was basically hijacked by this unseen third force, an unstoppable power that can override even the most perfect instruments. And to figure out exactly what this third force is, we first need to understand how airports actually work from the ground up. And that all starts with looking at the wind. You see, those runway numbers we talked about, they aren't random at all. They are meticulously designed around prevailing weather. Because when a plane takes off or lands, the absolute most important thing is a smooth, stable operation. And for that, airplanes desperately need headwinds. That's wind blowing directly into the nose of the plane. Since lift is generated by airspeed moving over the wings, a strong headwind acts like an invisible ally. It's a natural airspeed booster. If you've ever felt your plane bank pretty steeply right after takeoff, it's often just aligning with these invisible rivers of air. This is exactly why major airports, like Dubai International, align their physical concrete runways directly with the prevailing seasonal winds.
Headwinds are literally an aircraft's best friend. Let's put this into perspective with the massive Airbus A380, the largest passenger plane in the world. On a completely still day with zero wind, that incredibly heavy aircraft needs to hit a ground speed of 240 kilometers per hour just to force enough air over its wings to lift off. But if you have a 40 kilometer per hour headwind blowing straight down the runway, the plane only needs to hit 200 kilometers per hour on the ground. The plane lifts off seconds earlier, uses way less runway, requires less engine thrust, and saves massive wear and tear on the brakes when landing. It's a real game changer.
So because airports basically bow down to the wind, their runways are positioned at very, very specific angles on a compass. And this brings us right to the foundational code of those giant painted numbers. Let's look at runway 30L in Dubai. A full compass circle is 360 degrees, right? Well, the aviation world keeps things super simple by just dropping the last zero. So runway 30 is perfectly aligned at exactly 300 degrees on a compass. If a plane is coming in from the desert side and hits a waypoint at exactly 300 degrees, it glides in perfectly straight. Oh, and the L? That just stands for left, simply because Dubai happens to have two parallel runways. Now, there is a really cool magic number hiding within this code, and it's 18. Think about it. Every runway is just a giant straight line, which means it can be approached from two opposite directions. If you approach Dubai's runway from the desert, like we said, it's 300 degrees or runway 30. But if the wind changes and you have to approach from the Arabian Gulf side, it's 120 degrees, making it runway 12. The mathematical difference between the two ends of any runway on Earth will always be exactly 18. That represents a 180-degree straight line. Take the higher number, 30, subtract 12, and boom, you get 18. It's an incredibly elegant, foolproof system. But what happens when you have an airport where the wind doesn't just blow back and forth from two directions? Take Mumbai International Airport, for example. The geography there means winds change dramatically all year round. To handle this, they built intersecting runways, almost like a giant X. If the wind comes from the east, they use the runway pointing exactly 90 degrees. Now, you might think they just paint a giant 9 on the tarmac, right? But a single digit could easily cause a deadly miscommunication over a crackly radio. So they always add a leading 0. It becomes runway 09. And the opposite end?
Well, 9 plus 18 is 27, so you have runway 27 pointing west.
Okay, so the numbers are locked to compass degrees, and a compass angle never changes, right? Well, actually, scratch that. Let's look at Kristiansand Airport over in Norway. If you check out satellite imagery today, you'll see runways 03 and 21. But if you rewind the clock just 10 years, that exact same strip of concrete was painted as runway 04 and 22. In just one single decade, the runway mysteriously shifted by a full 10 degrees. The airport management didn't make a mistake. The concrete certainly didn't move. We are finally face to face with the mysterious culprit that crashed that Navy plane. Enter our mystery villain, magnetic drift. You see, our planet isn't just a solid, boring rock. Deep down in the center of the Earth, there is this massive ocean of superheated, molten liquid iron that is constantly swirling and churning around. This moving iron basically turns our entire planet into a colossal magnet, generating a magnetic field with a north and south pole. But because that liquid iron is constantly sloshing around down there, those magnetic poles are not fixed. They literally move. In fact, right now, the magnetic pole is drifting pretty rapidly across the globe, heading right towards Russia. And before we fully solve the mystery of our crashed plane, I just have to share this totally mind-bending fun fact with you. The little needle inside a compass is actually a tiny magnet itself, just balanced on a pin. And a basic law of physics is that opposite magnetic poles attract. So, if the tip of your compass needle is a north pole, it physically has to be attracted to a south magnetic pole. That means what we call the Earth's geographic North Pole, up near the Arctic, is actually, physically, our planet's magnetic South Pole. I know, it's totally counterintuitive, but it's exactly how the physics of navigation actually works. So, let's bring this right back to our 1970 disaster and how magnetic drift almost cost an entire flight crew their lives. That U.S. Navy flight crashed at McMurdo Station in Antarctica, which is located extremely close to the planet's pole. And because it's so close to the pole, the effects of magnetic drift are highly, highly exaggerated there. Now, no planes had visited that station for 6 whole months. During that gap, the magnetic field had shifted so aggressively that the compass heading they had on file literally became a dangerous illusion. The pilot's compass was pointing exactly where the runway used to be magnetically, but the physical runway? It was no longer there. But you know, the secret language of the runway doesn't just stop at compass numbers. As a pilot breaks through the clouds, those giant white stripes at the beginning of the pavement, the ones that look kind of like piano keys, they aren't just there for decoration. They're called threshold markings, and they instantly tell the pilot the exact physical width of the runway. 4 stripes mean you're landing on a tight 60-foot wide runway. 8 stripes mean 100 feet. And if you see 16 stripes like they have at Dubai International, you are looking at a massive 200-foot wide runway capable of handling the absolute biggest planes on Earth. Seeing these threshold stripes triggers this intense, high-speed visual sequence for the pilot. After flying over the threshold, the pilot tracks the distance calculators. These are sets of 6 stripes that tick off every 500 feet. Then, while hurtling toward the ground at over 300 kilometers per hour, the pilot locks their eyes onto the aiming point, which is marked by 2 massive solid white blocks. That is the strongest part of the runway and the ultimate target touchdown zone. But if the plane floats past those blocks and the final distance markers, they are running out of pavement fast. The pilot must push the throttle to maximum and execute a go-around to try the whole shebang again. But what about at night? What happens when all that helpful white paint is just swallowed up by the darkness? Well, airports transition to painting with light. As they approach, pilots look for bright green lights that indicate the safe touchdown zone. The edges of the runway are lined with white lights, but for the final 2,000 feet, they turn yellow, warning the pilot that the end is coming up quick. Right down the exact center line, the final 3,000 feet flash alternating red and white. And for the very last 1,000 feet, the lights turn solid red, essentially screaming at the pilot, "The runway is over, hit the brakes right now." Of course, sometimes the weather is just so bad or the fog is so unbelievably thick that even those brilliant lights are entirely invisible. But we're in the modern aviation era, so we don't just rely on compasses and visuals anymore. Major international airports utilize an ILS, or Instrument Landing System. Think of it as this invisible web of radio signals that connects directly to the aircraft's autopilot. It calculates the exact offset, the perfect 3-dimensional descent angle, which is known as a glide slope, and it can literally guide a massive jetliner safely down to the tarmac without the pilot ever needing to see a single piano key or aiming block.
Which kind of brings us to a huge question about the future of this secret language of runways. Earth's magnetic drift is accelerating. In places like Canada, airport staff were getting so exhausted with constantly scraping off and repainting these runway numbers that they made a radical decision. They are just abandoning the magnetic compass altogether and fixing their runways to true north using GPS satellites, because that's a pole that never physically shifts. It's incredibly efficient, for sure, but it forces pilots to rely heavily on screens instead of raw magnetic physics. So, with the poles shifting faster than ever, will this beautiful compass-driven aviation language eventually disappear from our airports entirely? I guess only time will tell.